Hello all, welcome back to Edumode tutorial series. I am Guru Renuka, instructor for the subject elements of electrical engineering. In this lecture, we are going to study the speed control of DC motors, that is the flux control method and the armature control method for DC shunt and DC series motors. So, the speed control of DC motors. Here, although a greater percentage of electric motors in service are AC motors, DC motor is of considerable industrial importance. That is because the principal advantage of a DC motor is that its speed can be changed over a wide range by a variety of simple methods. So, such a fine speed control is generally not possible with AC motors. So, in fact, fine speed control is one of the reasons for the strong competitive position of DC motors in modern industrial applications. So as we know, the speed of a DC motor N is directly proportional to EB by 5. In other terms, N equals to some constant K into V minus IA R by 5, where here R is the resistance. For shunt motors, R equals to RA, whereas for series motor, R equals to RA plus RSC, right? We have discussed this in the previous videos. So there are two main methods of controlling the speed of a DC motor. First one, it is by varying the flux per pole, and we call this method as flux control method. And the second one, it is by varying resistance in the armature circuit. Here CKT indicates circuit. Okay. We call this method as armature control method. So first let us see the speed control of DC shunt motors. In DC shunt motors, the first method, flux control method, is frequently used because it is simple and inexpensive. Okay, coming to the flux control method, it is based on the fact that by varying the flux per pole, the motor speed N can be changed because N is inversely proportional to 5, right? Okay, so so we call it the flux control method. In this method, what happens is a variable resistance known as the shunt field rheostat is placed in series with the shunt field winding. If you look at the connection, it's clearly evident here. So the shunt field rheostat reduces the shunt field current and hence the flux. So the shunt field rheostat reduces the ISH and 5. Okay. Then we can only raise the speed of the motor above the normal speed here. So this method permits to increase the speed in the ratio 3:1. So wider speed ranges can be, wider speed ranges tend to produce instability and poor commutation. If you see here the graph here, the above curve indicates speed with field rheostat and the below one, it indicates speed without field rheostat. See? So the advantages are, first of all, it is easy and convenient method, and secondly, it is inexpensive because little power is wasted in shunt field rheostat due to small value of ISH. And whereas the third one, the speed control exercised by this method is independent of the load of the machine. Okay, but there are disadvantages too. So the disadvantages, only speeds higher than the normal speed can be obtained. This is because the total field circuit resistance can't be reduced below RSH. Okay, and the second one, there is a limit to maximum speed obtainable. This is because the flux, if the flux is too much weakened, commutation becomes poorer. Okay, this is about the speed control method of DC shunt motors, and this is about flux control method. Next we will look at armature control method for DC shunt motor. So armature control method in DC shunt motor. Here this method is based on the fact that by varying the voltage across armature, back EMF and speed of motor can be changed. Okay, so this is done by inserting a variable resistance RC, that is the controller resistance, in series with armature. See the connection here. See, in this flux control method, a variable resistance shunt field rheostat is placed in series with shunt field winding, whereas here in the armature control method, control RC controller resistance is in series with armature. You got the difference? Yes. Okay, then we know this this is the connection and this is the graph. This is without controller resistance and this is with controller resistance. Okay, we know that N is directly proportional to V minus IA into RA plus RC, whereas this RC is the controller resistance. So due to this voltage drop in RC, EB is decreased, back EMF is decreased. Since the speed is directly proportional to back EMF, speed of motor is also reduced. And the highest speed obtainable is the normal speed, and this is obtained when RC equals to 0. And the third thing is it provides speeds below the normal speed. Okay. Then coming to the disadvantages, first of all, a large amount of power is wasted in this controller resistance as it carries full IA, right? See, the full IA goes through this. And secondly, speed varies widely with load. Since the speed depends upon the voltage drop in the controller resistance and hence on the armature current demanded by the load. And third point, output and efficiency of motor are reduced. And the fourth one, poor speed regulation. So due to above disadvantages, this method is seldom used to control the speed of shunt motors. So in this lecture video, we have finished the speed control of DC motors for the DC shunt motor. That is, we have discussed both flux control method and armature control method. Let's continue it in the next lecture video. Thank you.